A very good morning to all. Dear participants, today I am going to give a talk on NMR spectroscopy. And here, NMR spectroscopy is playing a very important role in the analytical chemistry. First of all, this NMR spectroscopy was introduced by Isidore Robbie in the year 1939. Okay, and actually, the NMR signals were observed by Purcell and Walsh in the year of 1945. Okay, and all nuclei with magnetic moment and angular momentum can be studied. And what type of the nuclei that are going to achieve in this case is H1, that is called popularly called it as a proton, and C13, it can be considered as a carbon 13. Another one is N15, that is nitrogen 15. What are the very significant contributions of NMR spectroscopy? Okay, mainly the accelerated organic chemistry research and most versatile technique for structural elucidation of complex natural products and study of macromolecular interactions, including the protein-protein and drug-protein structure, can be achieved. Okay, the major principle involved in the NMR spectroscopy is this one. A vector is present in the nuclear magnet. It undergoes the nuclear spinning. It is in, that undergoes the spinning means rotation. It undergoes the spinning like this. Okay, and it is a nucleus that undergoes a spinning. Okay, now here the spinning is behaves like a magnet. The spin is behaving like a magnet, and here the nuclear spin quantum number is considered as I is equal to 1 by 2. Generally, it can take 2i plus 1 orientations. They can be called it as a 2i plus 1 spin orientations. Okay, and here it can be considered as a half orientations. That means m1, that can be considered as a plus half, they can be considered as alpha, and minus half, they can be considered as a beta. And this energy can be explained, the energy difference can be explained with the delta E is equal to h nu. And here it is showing, it is not so simple. How the spinning can be observed, this can be beautifully shown in this particular diagram. Okay, and next one. Okay, and this is a beautiful diagram. It is the spin energy states are having the two types. One is a plus half or alpha and minus alpha. It is a one direction, clockwise direction and anti-clockwise direction. Depending upon the direction, we can consider as a plus half as well as a minus half. Okay, and the field difference that can be explained in this particular two aspects. Okay, and next one, here a spinning bar magnet, and the spinning bar magnet is having a particular angular momentum. Okay, and when the magnetic field is precise, what happens in this case is that precision frequency can be called it as a Lorentz frequency. Okay, and for that particular thing, the expression in this case is gh mu h and b by h, that is gamma h and b by 2 pi. Okay, and here the resonance absorption, it occurs when the Larmor precision frequency is the same as the frequency of the applied magnetic field. Next, here you just see how that can be achieved, how the frequency can be achieved, that is shown in this particular diagram. Okay, you see, okay, this is an anti-parallel direction, it can be considered as an anti-parallel direction. Okay, and like that you can get in this case. And you see this one, especially if it is in parallel in nature, it is having a low energy, where it is in anti-parallel direction, it is having the high energy in nature. Okay, what is h naught? H naught can be considered as a applied magnetic field. It can be considered as a applied magnetic field that we are explaining in the case of this particular h naught, in the case of this particular h naught. Okay, and next, I see this one. Suppose if there is no magnetic field, then what happens in this case is all with the vectors will move in different directions. Suppose if we can put some applied magnetic field, then all they go in one particular directions, in one particular directions. Okay, next, here there is no magnetic field is applied. Okay, that's what happens in this case is the spin alignment is randomly distributed. Okay, suppose if you can apply some external magnetic field, all the spins can be aligned in one particular direction. Okay, and that is the advantage of the magnetic field. You see this one. Okay, how that can be rotated by applying the magnetic field. The nucleus undergoes spinning in a particular direction. That is the basic principle involved in the case of the NMR spectroscopy. Okay, this x y z that indicates the axis, x axis, y axis, as well as the z axis. Next you see this one. Okay, the nucleus undergoes spinning. How the nucleus undergoes spinning in this case is with a precessional orbit. By applying the magnetic field, that undergoes spinning with a precessional orbit. Okay. Next, what is the instrumentation involved in this particular case? The instrumentation involved in this particular case is okay, and mainly you see that includes that it is a block diagram of this one. It is a sweep generator, it is a magnetic poles, it is a sweep coils, and is RF transmitter. They can be popularly called it as radio frequency transmitter. And here that is a sample tube. The sample can be held in this particular location. That is a sample tube. It undergoes spinning in this particular location, and in the between the two sides of the sample, it is having the sweep coils are there. Okay, and it is a radio frequency transmitter, and this can be called as radio frequency receiver. Okay, and here these are the considered as the two magnetic poles are there, and then it is a amplifier and followed by receiver and then recorder. Like that, these are the various components of this particular instrumentation of this particular. It is one of the important or one of the actual that is the instrument of this particular NMR spectrophotometer. Okay, and the manufacturer of this particular company is Varian. Okay, is one of the laboratory model NMR spectrophotometer. Okay, and here in the inside of the NMR spectrophotometer, how it can be appeared, inside how it can be appeared, and that can be observed in the case of this particular, in the inside of this particular thing that includes the so many components are there. All these can be observed in the case of this particular thing. Okay, it is the inside of the portion that is involved in the case of the NMR spectrometer. Okay, next, mainly we just observe this particular thing. What information we are getting? We are getting information about the protons. Proton can be called it as a H1. Mainly, what we are getting in this case is we are getting the number of signals that is there. Okay, how many number of equivalent protons are present? How many number of non-equivalent protons that are going to be present? And mainly it is related to the splitting of a signals, which includes spin coupling, that is related to proton neighbors, and relative intensity of the signals, it is related to integration, the ratio of the equivalent protons. And last one is position of the signals, that is related to the chemical shift, it is related to the magnetic environment of the protons. It is one of the best example. Here it is an example of ethyl alcohol. The formula is CH3CH2OH. The CH3 contains the 3 protons, CH2 contains the 2 protons, and OH contains the 1 proton. But all the protons are not at all equal. That is what we are explaining in this case. The nature of the proton is different, and the nature of this proton is different, and the nature of this particular proton is become different. Next, we also get the relative intensity of the peak. So, okay, and here what happens in NMR? The amount of radio wave energy absorbed is proportional to the peak area. Okay, and here how the peak areas can be measured by the process that is called as a integration. The relative intensities of NMR signals is mainly proportional to the number of equivalent protons. Okay, always the integrals do not always correspond to exact number of protons. Okay, suppose if integrals of 2 is to 1 might be considered as a 2 protons to 1 proton. Like that, the integration can be achieved. Okay, and here also one more important aspect is NMR spectroscopy. Popularly, the abbreviation is NMR. In detail, it can be called nuclear magnetic resonance spectroscopy. This nuclear magnetic resonance spectroscopy, it is having a very wide applications in analytical chemistry. Okay, what are the important applications of this nuclear magnetic resonance spectroscopy? It gives mainly it is widely useful for the structural elucidation. Especially, it is having a very good number of applications in the natural product chemistry and synthetic organic chemistry. Natural product chemistry as well as a synthetic organic chemistry. Okay, and next, it is mainly used, and here also, especially why we are explaining in this particular case is mainly in the natural product chemistry or synthetic chemistry, we have to elucidate the structure. How the structure can be elucidated, especially by using the NMR spectroscopy. by using the NMR spectroscopy. Next, study of dynamic process. What is the meaning of the study of dynamic process in this case is mainly it includes the reaction kinetics or study of equilibrium. These can be considered as a study of a dynamic process. Next thing is structural studies. Mainly we can analyze various aspects of the structures like proteins and DNA complexes and polysaccharides. Okay, and these proteins are very very large molecules, and DNA is also very macromolecules. Macro means larger in size. Next, this NMR spectra is also playing a role in the drug design also. How NMR spectroscopy is playing a role in drug design, especially in the SAR, means structure activity relationship. Structure activity relationship, it is widely useful. Next, medicine. In the medicine, it is having a role in the MRI imaging of the brain. MRI means magnetic resonance imaging. Especially in the MRI imaging of the brain is magnetic resonance imaging of your brain. Okay, that is a major important aspect. And not only the brain, these MRI scanning can also be useful mainly for study of the abdomen, kidneys, and pelvis and etc. Okay, it is also useful for detection of the hydrogen bonding also. It is also useful for detection of the hydrogen bonding also. Okay. Next, another important application of these things is structural determination of the complexes, and some of the complex molecules, the structure can be determined by using this one. A distinction between the keto enol tautomerism and keto can be converted to enol, and enol can be converted to keto form. Okay, an intramolecular conversion and also exchange effects and intermolecular exchange reactions and determination of activation energy, elemental analysis, rate of reaction, identification of structural isomers, and detection of aromaticity are there. And especially the nucleus, all these things, how that can be explained depending upon here. This can be explained based on natural abundance and relative sensitivity. Depends upon the natural abundance and relative sensitivity while explaining this one. And one more related aspect is the continuous wave spectroscopy. Continuous wave spectroscopy. They can be popularly called as a CW spectroscopy. It is one of the important aspects in relation to this particular CW spectroscopy. And another related word is the Fourier transform spectroscopy. And this can be called as FTNMR. What is the, it is similar to that of the FTIR spectroscopy. And FTNMR means that it involves the irradiating the simultaneously with more than one frequency. Irradiating simultaneously with more than one frequency. It is called as FTNMR, mainly to use the short pulses of radio frequency. That is comes in this case. That one more important thing is the short burst of energy is called as a Fourier transform. Okay, it relatively easy to use. Okay, and short radio frequency pulse to excite the NMR spectrum. Okay, the time is very very short, especially it is millisecond to the microsecond. This is the time gap is very very less, very very less. Okay, and especially low abundance leads to noisy spectral data, and weak signals are cluttered with the background noise, electronic noise. And mainly how the noise can be eliminated, the noise is eliminated by running the hundreds or thousands of spectra and averaging the data. Noise averages to zero. Always the signals can be standard out in this aspect. And another related term in this case is C30 NMR spectroscopy. The NMR spectroscopy is having the two types. One is proton NMR, next one C30 NMR. The proton NMR is mainly useful for study of the hydrogen atoms. C13 is related to the carbon isotopes, carbon hydrogen isotopes. Mainly low abundance overcome by signal wave averaging and Fourier transform NMR. Mainly, it increases the sensitivity and the speed of the operation. Okay, and here also in the case of C30 NMR, every atom is gives a different signal. Okay, and here one more point in the important aspect see that NMR is coupling constants. Okay, in the coupling constants, the range is 100 to 250 hertz are common, which means that there is significant overlapping between the signals. Okay, and here the splitting patterns is very very difficult. The most common mode of operation of a C30 NMR spectrophotometer is a hydrogen decoupled mode. Hydrogen decoupled mode. Okay, and here one more important regarding it is the appearance of the how the spin coupling is going to happen. So in the case of this particular C13 NMR, okay, and this what is the this J? J indicates the coupling constant. The J indicates the coupling constant. These are the various chemical shift values, especially C13 NMR, the NMR spectroscopy. The chemical shift is also playing an important role. Okay, and here it can be considered as a C13 NMR. How the C13 NMR can be influenced, that I can explain in this case. Okay, next comparison of H1 and C13 NMR spectroscopy. Okay, and you can explain the H1 is having 99% abundance, C13 is having the 1.1% natural abundance. Okay, and both are having the different purposes. The proton H1 is for the explaining about the proton nature, C13 is related to the corresponding carbon atom. Okay, and here also basing on this particular thing, how to compare the proton and C13 NMR spectroscopy, especially the C13 requires the FT NMR. We have already told that FT NMR means that Fourier transform NMR. Okay, mainly because the signal for the carbon atom is 10 power minus 4 times weaker than the signal for the hydrogen atom. A signal for the C13 nucleus is only about 1% as intense as that of the H1 because of the magnetic properties of the nuclei. And in addition, at the natural abundance level, is only 1.1%. 1.1%, especially of all the carbon atoms of the sample are C13. Okay, and here also, what is the differences between these two? Especially if we can study the nature of the protons, we can go for the proton NMR. If we can study the C13, then you can go for the carbon 13 NMR. Okay, and like that we can differentiate the proton NMR as well as a C13 NMR spectroscopy, as well as C13 NMR spectroscopy. And here both the techniques are having their own advantages. Both techniques are having their own, but ultimately the principle is become same. That can be considered as a proton nature as well as a C13 nature. C13 nature. But ultimately the purpose is become same. What is the purpose? It gives information about the characterization of the structure of the sample. Mainly, we will get information on the characterization of the structure of the sample. The structure can be characterized by using this particular technique that is considered as a C13 NMR spectroscopy. Next, one more important point in the case of this particular aspect in this case is, suppose if you can take an organic compound. In this particular organic compound, all the atoms or molecules are not having the equal nature. It may looks like a similar, but they are not similar. But they are not similar. They are having their different independent properties. They different independent properties. That's why we can differentiate one with another by going for the nature of atoms. By going for the nature of atoms. Okay, and like that you can differentiate the proton NMR from the C13 NMR. Okay, and here one more important point in this case is the chemical shift is one of the important parameters in the case of this particular proton as well as C13 NMR. The chemical shift is considered as one of the important parameters for the proton as well as a C13 NMR spectroscopy. Okay, and next another important point in this case is in the case of this particular proton and C13 NMR, which one is having more advantages? Means that the values, the chemical shift values is also different in the case of the proton NMR and C13 while observing the spectrum itself. We can differentiate whether the spectrum is of proton NMR or is of the C13 NMR. That we can differentiate by using this particular spectroscopy. And one more important point in this case is the cost of the equipment of this NMR spectrophotometer is very high, very high. Okay, and because of that particular reason, only R&D centers and the central instrumentation laboratories of the various central government organizations, they only maintain these particular instruments. They only maintain these particular instruments. Okay, and that is the advantage of the. And here also one more point in this case, nowadays the we are using the hyphenated techniques, means combination of the one technique with other technique. Like that here also what we are doing in this case is the NMR technique is combining with other analytical techniques. It is combining with the other analytical techniques also. Okay, like that what happens in this case is two types of the principles will be joined together, then you will get the best output of that particular analytical technique. Okay, and suppose if you can take NMR and mass. Okay, if the NMR technique and mass both can be connected together. Okay, and what happens in this case is these NMR MS can be classified as a hyphenate techniques, because the combination of NMR principle with mass technoscopy principle, then that will give say two things which can be done in a single instrument. That is the advantage of this particular NMR technique with this particular MS technique. Okay, and nowadays majority of the analytical instruments will work on the hyphenated only. Why? Because in this case is we can do it all the things at a time. We can do it majority of the things at a time. That's why what happens in this case is we can do it the things in a better manner. We can do it the things in a better manner. Like that, what happens in this case is the separation can be achieved in a good way. The separation can be achieved in a good way. Okay, and yes, generally, if we can take any synthetic organic chemistry or the medicinal chemistry or pharmaceutical chemistry, if we can synthesize one compound, then for that compound, the first step in this case is we have to go for the proton. If you will get a good peak with a good structure of that particular molecule or novel structure, then you can go for the second type. The second type is considered as a C13 NMR. Okay, C13 NMR. Like that, the separation can be carried out. The first one is proton, and then followed by the C13 NMR. Like that, we can do it one by one. Okay, but every technique is having their own advantages. So whether we can't say whether proton NMR is excellent or C13 NMR excellent, like that we can't say, because these techniques are having their own independent importance are there. We can't say which technique is become more predominated one, which technique is considered as a more predominated one. Okay, and one more important thing regarding this thing in the case of this proton C13 in this case is natural abundance. Natural abundance. Okay, and here also, suppose if you have already covered that particular indirectly in the previously, suppose if it is a proton NMR, the natural abundance is 99.9%. What is the remaining thing? Only 1.1%. The C13 NMR is having a natural abundance is 1.1%. Like that. Okay, that is proton NMR as well as C13 NMR, they are having their own advantages. Okay, basing on this, dear audience, what are the various components that are covered in this NMR spectroscopy is what is introduction to NMR spectroscopy, what is the coupling, what is the spin constant. Okay, next thing, what is the principle involved in NMR spectroscopy, and what is the instrumentation involved in NMR spectroscopy. Next thing, got important thing in this case is what are the important applications that are there in NMR spectroscopy, because this NMR spectroscopy is having the wide applications in different areas like organic chemistry, inorganic chemistry, physical chemistry, pharmaceutical chemistry, and natural chemistry, and analytical chemistry. Okay, and like that, it is having the wide number of applications in different areas. Okay, and then we can say that these NMR spectroscopy is one of the widely acceptable technique for pharmaceutical sciences. For pharmaceutical sciences. Okay, and participants, thank you for giving me this particular opportunity. Thank you all.